All right, hello again. In this video, working through number 3 of the practice set of questions for this week, the actually second part of the practice set of questions for this week, which I'm coining as more complex trig equations because there's other things happening here. So looking at this, we want to solve what values of x we take the cosine of, then subtract 2/3 pi and which result in an x value of 1/2. And we're looking at x values between -2 pi and +2 pi that we're going to input here. So looking at this, what we're going to do is we're taking the cosine of something that isn't just a variable. We're taking the cosine of an expression. So we're going to set that expression equal to another variable. And that variable we've been using is u. So we're going to say let u equal what the argument of this cosine is. So x minus 2 pi over 3. Now looking ahead at this, I'd expect something to be pi thirds in this problem because this kind of seems like a weird value to be subtracting. Even though I wrote the problem, it's going to happen ahead of time. So what this leaves us with is a trig equation that says, well, what values do we take the cosine of? What u values do we take the cosine of to result in a value of 1/2? So when we're thinking cosine, we're thinking x values on the unit circle. So what angles and radians, because that's what our domain is restricted by, produce a x value or have an x value of 1/2? Well, working around our unit circle, we're looking at x values of 1/2. So an x value of 1/2 is going to be pi thirds, so that's one of our solutions. So u can equal pi thirds. And then as we keep working around, well, we want 1/2 as our x value. These are all negative x values here because we're going to the left. So the other x value of 1/2 is 5 pi thirds. So 5 pi over 3. Now this is for our domain from 0 to 2 pi. If we want to go -2 pi, we subtract 2 pi from these values to get the other ones. Also, we can have a u value of pi thirds minus 2 pi. Well, in terms of thirds, if we think about that, 2 pi would be 6 pi thirds. So we're subtracting 2 pi, but we're writing it as 6 pi thirds. Or 5 pi thirds minus 6 pi thirds. Again, that's just 2 pi with a common denominator to subtract these. So our u value is -5 pi thirds, and the other u value we have is -pi thirds. So there's actually 4 u values here that satisfy the equation cosine u is 1/2. And those, if we get them all in one place, would be u values equal to -5 pi thirds, -pi thirds, pi thirds, and +5 pi thirds. So these are the values that satisfy the equation that we've substituted, but now we need to say, well, I don't want u, we want to solve for x, so we need to solve for x. Well, how we get x is we know u is x minus 2 pi thirds. So if we want to solve this for x, well, we add 2 pi thirds. So u plus 2 pi thirds is going to produce the x value. So we take every u value and we add 2 pi thirds to it. So let's go ahead and do that. So our x values would be -5 pi thirds plus 2 pi thirds. So that would be -3 pi thirds. Our next x value plus 2 pi thirds, so -pi thirds plus 2 pi thirds would be pi thirds. Add 2 pi basically to our numerator is what's happening because we have common denominators. So 3 pi thirds. And add 2 pi here, so we'd have 7 pi thirds. Well, 7 pi thirds is actually outside of our domain that we can have. So as we simplify these down, -3 over 3 is -pi. Pi thirds doesn't reduce. And then 3 pi over 3 is +pi. And 7 pi thirds is actually going to equal 2 and 1/3 pi. I don't know why I was writing that in that way. So 2 and 1/3 pi, which our x values can only be as large as 2 pi. So that is outside of our given domain. So we scrap that in the end. So 3 answers here to our worked problem.